Okay, now we are looking at day 2's guided practice over permutations. So the first one, we have 6 factorial. So you can type this in as 6 times 5 times 4 times 3 times 2 times 1, or you can just do your 6 and your factorial. And we get 720. Our next one, we want 7 factorial divided by 3 factorial. Again, you could do 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, or 7 factorial over 3 factorial. And we get 840. So this next one, we do 8 factorial over 8 minus 3 factorial. 8 minus 3 is 5 factorial. We've got 8 factorial over 8 minus 3 factorial. We get 336. Number 4, how many 5-digit ID numbers are possible if all 10 digits may be used and digits may be repeated? So on this one, we can repeat digits. And we have 5 places to fill. So we've got 5 spots that need filling. So we're going to write down 5 spots. And then we can repeat. So we have 10 options for each of these because we can repeat. So 10 times 10, 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. We've got 100,000 different 5-digit ID numbers. Number 5, how many 5-digit ID numbers are possible if all 10 digits may be used and digits cannot be repeated? So again, we have 5 spots to fill. We're trying to make a 5-digit ID number. So we need 5 blanks. And this time, digits cannot be repeated. So once we put down a number in that first blank, we can't use it again. So 9 times 8 times 7 times 6. And that equals 30,240. Different 5-digit ID numbers. Okay, so some of you may be confused by that. So a picture. So if you have a bag with your numbers in it, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. You have 10 options in that bag for that first draw. And once you draw out that first number, let's say the first number is a 3, we only have 9 digits left in that. So the next number can only be pulled from 9 digits. So let's say that the next number is 5. Now, if we count, there's only 8 possible options left for the next one. So we draw another one. Let's say it's 7. And now there's only 7 possible options left for our next draw. We draw that one. Let's say it's a 2. And that leaves us with only 6 possible options for our last draw. So it's an 8. So if you need to draw out examples like that for some of the problems today, it might help you figure out what should go in your blanks. The next one, how many 5-digit ID numbers are possible if an ID must start with a non-zero digit and digits may be repeated? Okay, so on this one, remember that digits mean anything from 0 through 9. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those are our digits. Now it says that the first one must be a non-zero digit. So we have 5 blanks. The first one has to be a non-zero digit. So again, if you have a bag, first one can't start with 0, so we can't have 0 in that bag. So it's 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we have 9 possible options for that first draw. Let's say that we draw out a 2 for that one. Now we can put 0 back in because the next number can be 0. So how many digits are in there? 9. And then once we draw that, 8, we only have 8 possible options left. And once we draw all that one, it's 4. We only have 7 possible options left. And once we draw that one, we only have 6 possible options left. So we've got 9 times 9 times 8 times 7 times 6. And that gets us 27,000. Hold on. I think I misread something. So on this one, I did misread it. So this would be a different problem. This one says that the digits can be repeated. So that's really important to read. Digits may be repeated. This one would be if the digits weren't repeated. So instead of 9 times 8 times 7 times 6, once so we have a bag, 1 through 9 in it. So we have 9 options for that first draw. Once we draw one, we can put 0 back in. And on this one, it doesn't matter what we drew on that first one. It can go back in as well. So we have 10 options for that second one. And we'd have 10 options for the next one, and the next one, and the next one. And that would get us 90,000 different ID numbers. So make sure you're reading the problems today, because it changes what you do. The next one, Max forgot to study for a 10-question true or false quiz on Friday. Max wants to determine the probability of making a perfect score if he randomly guesses true or false on each question. How many different ways can he answer the quiz, and what is the probability he makes a perfect score? Okay, so there are 10 questions, so we need 10 blanks. Okay, now, how many possible ways can we answer the first question? It's true or false, so we got 2 answers. How many possible ways can we answer the second one? 2, because there's 2 answers. Third, 2. Fourth, it's also 2. Every single one of these is 2, because every single question is either a true or a false for an answer. So that is 2 to the 10th power. Which is 1,024 possible ways to answer this quiz. Now, how many ways can you make a 100? There's only one way to make a 100. So the probability of making a 100 is 1 in 100,024. And if you approximate that to a decimal, we get 0.000977. Okay, yes, I would like you to use both the fraction and the decimal for your answer. Because sometimes on the test, you're going to have fractions, sometimes you're going to have a decimal, sometimes you will have a percent. Number 8, which state name has the most rearrangements of a letter in its name, Florida or Tennessee? So we need to look and see how many different ways we can rearrange these letters. So we've got Florida first. So we need to find our rearrangements for Florida and for Tennessee. So for Florida, there are 1, 2, 3, 4, 5, 6, 7 letters. So we got 7 factorial. Over it, do we have anything that repeats? F doesn't repeat, L doesn't repeat, O doesn't repeat, R doesn't repeat, I doesn't repeat, D doesn't repeat, A doesn't repeat. So we don't need to put it over anything. So we've just got 7 factorial for Florida. And that gets us 5,040 for Florida. Possible rearrangements. Again, that one's for Florida. Now let's look at Tennessee. Tennessee has 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So we've got 9 factorial, and then we need anything that repeats. So t doesn't repeat, e does repeat, and it repeats 1, 2, 3, 4 times. So we've got 4 factorial. N repeats 2 times. 2 factorial. Already done e. S repeats 2 times. So we've got 2 factorial. Again, already looked at e. So we've got 9 factorial over 4 factorial times 2 factorial times 2 factorial. Now, when you put this in the calculator, you need to make sure that 4 factorial times 2 factorial times 2 factorial is in your denominator. It is at the bottom of your fraction. So control divide, 9 factorial. And my way to make sure that we are completely at the bottom of our denominator is to put parentheses around it. So 4 factorial times 2 factorial times 2 factorial. Like it says 3,780 rearrangements for Tennessee. That means that Florida has the most rearrangements. Number 9, a bag contains 9 chips, of which 4 are red and 3 are blue and 2 are white. How many unique permutations, ordered arrangements are possible using all 9 chips? So it's just like what we did on the last one. So we have a total of 9 possible chips. So we've got 9 factorial. And we need to take out the repeats, 4 factorial, 3 factorial, 2 factorial in the denominator. Again, control divide, 9 factorial over, put your parentheses, 4 factorial times 3 factorial times 2 factorial. And we get 1,260 possible arrangements.